Hello everyone. So today what we will do is we will look into like the last class. What we did was we uh, talked about a movie recommendation system, like a recommendation controller, where the user passed on the language and the genre of the movie, and our LM system gave a top five recommendation, right? So using the query that we have built. So, so in today's one, what we will do is we will try to create a basic rack of pipeline, right? Like rack system using Spring AI. So, to give a brief, so I'll discuss rack in another video, the property. So here, let me just give you a brief about rack. So what happens in the rack system is like in general, any LLM model is trained on certain amount of internet data, right? So the model knows all this like internet data that it has trained upon. And then when we ask some question, it gives me answer based on that data, right? Whatever learned knowledge it has, it will give answer to based on that. Now, say suppose I have some custom data, right? Some personal data or other information which is not there in the internet, or probably if it is there, it's hidden or like it's private, right? In that case, if I have to use that data, how do I use, right, in my LLM system? So that's where React comes into picture. So what we here React does is, so once we give that data, right, suppose I have a document of 100 page, right, or you can say a book of 100 page book. So I want to fetch information from that book, right? So in that case, what we do is we feed our book information, then we break it down into chunks, right? So what we call is embeddings here. So and then we like from the chunk we create embeddings, and we store that embeddings into an index. We have already discussed all this in another video, like when we created an index in our Jupyter notebook. So here I just giving you a brief. You can watch the other video maybe for even better understanding. So here, like the RAG system, so we create an index out of the document, right? So there, each chunk will represent at like a unit of information, which is which the we index it, right? So we call it as vector indexing. So once we are indexed, we have indexed it. Now, if we call, right, if we make a query into that index, then what happens is it will give me relevant information. Let's suppose if I'm talking or if I'm querying who is the author of the book, so it will give fetch five chunks information from that book, which talks about author of the book, right? So that would like we can have the closest information from that index, gather the closest information from it, and then we'll use it. So in the RAG system, what happens is once we created the index, now what we do is we query, right? So suppose I'm making a user query, so I'll fetch relevant information based on that query from that our vectors too. So in that, what happens instead of, so in this case, what's the benefit of using this? So if you see, the book was of 100 page. So basically, we have a lot of information. So in our context window that we pass in our LM, it will be huge context window. We don't want that, right? So what we want is we want only relevant information. So which we want to fit in our context window. So that's why we use this index technique, indexing. From the index, we will fetch that relevant information, and that information will pass into our context window, and that basically then the LLM knows like this is the information. From there it will give the answer, right? So that's how basically a simple RAG would work. So here what we are trying to do is we have we've already created an index and we have published in Pinecone, right? So I'll just give a quick few you know, when we build that information, right, index, so we skipped few information that we didn't pass. So the one key information was in the metadata we have to pass this document content, right? So here document content, it's basically each like in if you go through this video, so they basically that the chunk that we have broken down into from the document, like Suppose from the document, each line is our one chunk, right? So each line will be our one document content, and we are making it a text node. So which is basically used for the indexing purpose. So this is needed for our Spring AI Java applications to know understand if this text node corresponds to which line of the document. So there is one information that was skipped in that video. So because it was in while indexing, we don't need that information, but but by using it in Java Spring AI, we need this information, right? So now let's go to the code. So here, the main first we'll go to the POM file. So what we need is this is Spring AI Pinecone store is one of the package that we need because we are using Pinecone, and the other is the advisor, vector store advisor. So these are the two dependency that we will use in this project, right? In this now and then the fixing properties we have to use because we've created the index in Pinecone. We need the API key and then the index name to fetch this information, right? The index information. And while creating that index, we used text embedding 3 small, which is an OpenAI embedding module, right? And the dimension was 500 words. So while fetching also, we need to have the same parameter, right? The text embedding 3 small and dimension. So also we have to use OpenAI. So in our previous movie recommend API controller, we use Grok API because it was giving us free like daily limit. So we use that, leverage that to build our application. But because here we are using OpenAI text embedding 3 small, so in this case we will be going with the OpenAI token, right? So we have to create an OpenAI key. So for this we have to spend some bucks, but which is worth it if you are going to do projects in OpenAI like in Learn. So and yeah, you can just credit $5 worth of bucks, and that would be sufficient for your development work, right? So once you create this API, you can just input all this information here. So next is we have to configure the Pinecone. So here, the API key we are fetching from our properties and the index name from the properties file, and we are building the Pinecone vector store. So this is the embedding. It will fetch the details embedding model from the properties file, right? And then we are putting the API key. So this creates our Pinecone vector store. Now, if I go to my controller, so this is my basic screener controller. So here, this is almost the same thing as we have done in a movie. So only difference here would be internally the vector store would be a Pinecone vector store, right? Because we have configured that thing. And then if we go to the ask endpoint, so this is a system prompt. So in RAG system, one of the most crucial thing is to build the proper prompts that we want to use for the query. In general, in LLM, prompting is one of the key part of query. So these are prompt you can go through later on. So I'm not going to deep into this for now. This already we have explained it in our Jupyter when we have done in Jupyter mode. The same thing, right? We have facts information. So here we are just using Java Spring AI. We're doing it through that. So now we have to be the model, a LLM model, and make the call, right? So it's here now it is pretty simple. Everything is being handled by Spring AI. We have to just use the proper formatting in the calls, right? So here we are doing system using the system prompt, then the advisor. So here we are using this question answer advisor. So this comes from the dependency that we have used, vector store dependency that we have used from their advisor, right? So we have used this vector store advisor, Spring AI advisor vector store. From this, we will be able to use the question answer advisor. So what it does is internally, and we are passing the vector store. So internally, what it will do is it will go to the vector store, the question. So this is the question that we are passing from the like whatever question we want to query. So this is the query. So and we are fetching it from our request. So it will go to the vector store and it will fetch all the relevant documents based on this question, and it will give it to this advisor does it, right? This question and answer advisor does it internally. So it will give that document, whatever related document is there, it will give it to the model, and then we are making this call and we are fetching the runtime, right? So internally, how it works is like something like you are doing a similarity search query. We are creating a so here query. If you see, it will be the question and top whatever like top 5 relevant data we are fetching, and this is the documents. So we'll pass these documents. So these are the information which will go into the context window, right? So this is what happens internally. So which is being handled by question answer advisor. So this will do all those. So once this is being, so this is it. Like we are all ready. So now if I make the query, so I want goes again hit the query. We already did it before. So like say suppose my question is companies having no tag. So we want to generate a screener query based on this. So what it will do is it will give me this result as tag equals to 0, right? So now if I go to query, because query screener only understand this kind of a information, right? So it has these ratios, inbuilt ratios. We have to use that only. So here if I do, so I will get this results, right? So this is how like from our query, actual query, which is a user like a human text, we are converting it into a screen code. Right? So this is how, so this entire thing in we have done it in our Jupyter notebook. This is basically how we are doing it using Java Spring. So here the benefit of doing this is we all know like in AI/ML system, like most of the works are like because we have to do a lot of development work, right? Generating prompt and all those, experimenting with prompts and other information. So generally the preferred option is going via Jupyter Notebook, right? So the motivation was what if like we experiment in Jupyter Notebook, we create the index, and then we want to use that index, right, in our thing, in our Java application. So that's the like motivation for doing this work. So here we're basically doing that. So we are taking the index from Pinecone and then we're making the query. So in our subsequent videos, what we will do is we will like also like build the index in our Spring using our Spring AI itself, and then we will again fetch this, right? So no, yeah, with the next video, and then probably yeah we have other things also in line up, like we can use a Redis. How we can leverage Redis to faster to store documents and everything. So we'll take it in our subsequent classes. Right? So yeah, so this is it for now. Thank you.